The ground beneath you feels like the one solid thing in the world. It isn't, and once a century, somewhere on Earth, it proves it, by moving with the force of 100 million atomic bombs. This is the story of the most powerful earthquakes ever recorded, and of a strange, hard limit. Because unlike a storm, an earthquake has a ceiling. There is a magnitude the Earth simply cannot reach. So to break that ceiling, we'll have to break the rules. Welcome back to Dies Irae Hypotheticals, where we take the worst disasters on record and ask how much worse they could get. Everything in the first half actually happened. Then we push the science to its absolute limit, and every speculative scene is labeled on screen like this. This is not emergency guidance. It's a story about energy, rock, and a planet's structural limits. May 22nd, 1960, southern Chile. For 10 unbearable minutes, the ground heaved, the most powerful earthquake ever recorded by science. A slab of the Earth's crust 1,000 kilometers long, longer than California, lurched beneath the continent in a single motion. Its magnitude, 9.5. The coast dropped 2 meters as we watched. Minutes later, the sea came back, a wall of water up to 25 meters high that erased entire towns. And then it kept going. The tsunami crossed the entire Pacific at the speed of a jetliner, killing 61 people in Hawaii, around 140 in Japan, a day later, half a world away. This single earthquake released roughly a quarter of all the seismic energy the planet let go in the entire 20th century. The death toll has never been settled. Estimates run from about 1,600 to several thousand. It was so large it did something never observed before. It made the whole planet ring like a struck bell, standing waves running through the entire Earth for days. Studying that ringing, scientists built the very scale we still use to measure earthquakes today. Remember that scale? It's about to matter. 4 years later, Good Friday 1964, Alaska, magnitude 9.2, the second largest quake ever recorded, and the largest in North American history. The ground shook for nearly 5 minutes. In Anchorage, whole neighborhoods slid toward the sea as the soil beneath them turned to liquid. And yet, here is the haunting part, the shaking barely killed anyone. Of about 131 deaths, roughly 122 came from the water, and only about 9 from the shaking itself. Most weren't even from the main tsunami. They came from local waves thrown up by undersea landslides within minutes, with no warning. The largest reared up 67 meters, over 200 feet. The waves killed in Oregon. In California, more than 1,500 kilometers away, they drowned 10 people in the town of Crescent City. Alaska did something else. A geologist named George Plafka mapped how the coast had risen and fallen, and realized it could only mean one thing. The crust had slipped on a vast, gently tilted fault, diving under the continent. It was decisive field evidence for a then radical idea, subduction, and it told us exactly which faults make the monsters. Here's the scale and the trick inside it. Magnitude isn't linear. Each step up is about 32 times more energy. Step up 2 whole numbers and you've multiplied the energy 1,000-fold. The old scale couldn't even keep up. On it, Chile and Alaska looked almost the same size, both around 8.4. But that scale saturates. Past a point, it simply stops climbing. The truth was that Chile released about 10 times more energy than Alaska. To see that, we needed a new measure, moment magnitude, built from the size of the rupture itself. You'll hear that these quakes equal hundreds of millions of atomic bombs. That's a mistake. It confuses the earthquake's size with its energy. The honest number for a magnitude 9 is closer to 3,000 Hiroshima bombs of radiated energy. Still almost beyond comprehension, but it points to the real question. How high can this number go? Magnitude is set by one thing above all, the area of fault that breaks. And only one kind of fault is big enough to reach magnitude 9, a subduction megathrust, a gently tilted slab hundreds of kilometers wide and 1,000 long. The Earth's longest faults set the ceiling. And the ceiling is low. The largest quake we've ever seen, Chile's 9.5, is probably near the limit of what the planet can do. A magnitude 10 would need a single unbroken rupture 8 to 14,000 kilometers long, about a third of the way around the Earth. As the US Geological Survey puts it, no such fault exists, and if it did, it would wrap around most of the planet. So here are our three scenarios. Tier 1 is real and overdue. Tier 2 sits at the absolute edge of physics. And Tier 3? For Tier 3, we'll have to stop using a fault altogether. Tier 1. Off the coast of the Pacific Northwest lies the Cascadia subduction zone, and it is locked, loaded, and overdue. It last ruptured on the night of January 26, 1700, a magnitude 9 we know about only because its tsunami was recorded across the ocean in Japan. These happen about every 500 years. The clock is well into the window. When it goes, the shaking will last 4 or 5 minutes across a region of millions. But the shaking isn't the worst of it. On the outer coast, the tsunami arrives in as little as 15 minutes, faster than any warning, faster than most people can climb to high ground. Official estimates run to roughly 13,000 dead across Oregon and Washington. This is the grounded scenario. The only question is the year. Tier 2, we leave the record behind. Imagine not one segment failing, but the entire chain of trenches off Japan unzipping in a single continuous rupture, the 8 to 14,000 kilometer break that defines a magnitude 10. Nothing like it has ever happened. It sits at the outermost edge of what physics permits. A magnitude 10 wouldn't shake for minutes. It would shake for the better part of an hour. And Tokyo knows what comes next. In 1923, an earthquake there killed over 105,000 people, and nearly 9 in 10 died not from collapse, but from fire. Scale that to a magnitude 10 beneath the largest urban region on Earth, and the firestorm becomes the disaster. Japan already projects that a mere magnitude 9 could kill nearly 300,000 people. A 10 is a number the models were never built to hold. Tier 3. And here's the twist. Los Angeles sits on the San Andreas, but the San Andreas is the wrong kind of fault. It's a near vertical crack only about 20 kilometers deep, so it can grow longer but never wider. Which means Los Angeles physically cannot have a magnitude 9. Its worst possible earthquake is a full magnitude smaller than Seattle's or Tokyo's. To give LA something bigger, the Earth is no help at all. Here, physics ends. So let's break the rules on purpose. Forget what the faults allow, and imagine the ground beneath Los Angeles ripping open at magnitude 10.5. The absolute ceiling of the scale, a tremor no fault on Earth could ever generate, least of all this one. To put a number on the impossible, nothing in the seismic record comes close. Valdivia, the most powerful quake we have ever measured, was a magnitude 9.5. And on its own, it released nearly a quarter of the 20th century's seismic energy. A magnitude 10.5 releases more than 30 times that much energy. Centuries of the planet's earthquakes, unleashed at once, beneath a city of 10 million. At magnitude 10.5, the question stops being how many buildings fall. It becomes whether the basin itself holds together. This isn't a forecast, it's the edge of the possible, drawn so we can finally see where the real danger lives. And it lives quietly, off the coast of Seattle. So come back to solid ground, to what we can actually do today. We now have seconds to minutes earthquake early warning, enough to stop trains and halt surgeries. We have building codes that turned Anchorage's later quakes into footnotes. And on the coast, the single most important number is the one Alaska and Chile taught us. When the ground shakes hard near the sea, the water can arrive in minutes, so you climb immediately without waiting to be told. We can't make the plates stop moving, but preparation is the difference between a disaster and a catastrophe, and that difference is measured in tens of thousands of lives. One last thing about Chile, 1960. 2 days after the great earthquake, the ground opened in a different way. A volcano, Cordon Caul, roared to life, apparently shaken awake by the quake. Which is where we go next. Fire instead of motion, the most violent eruptions in Earth's history, and how close they've come to ending us. Sources are in the description and pinned comment. If you want to keep standing at the edge of the possible with us, Subscribe and we'll see you at the next catastrophe.